This is Michael Rizzo. I'm going to be explaining my project approximating the solution to the Poisson heat equation, which is negative u double prime equals 2 pi squared times sine pi x times sine pi y. This is using bilinear elements. And what this heat equation does is it emulates heat traveling through a 2D plane. And bilinear elements is it's linear in x and y. Basically, at 5 nodes, it starts off as a diamond, and as you get more towards 100 nodes, it's going to be more oval shape or circular. It just keeps getting more and more accurate. This was all done in Python 3. This was my final Python 2 actually. This was my final project at Florida State University, where I graduated with a degree in computational science. This is a project I had lots of fun with, and this at 30 nodes is looking pretty close to the final solution. The libraries used were matplotlib to plot the details, and multiple libraries for the needed conversion from a 1D finite element code to a 2D finite element code. We just keep watching, it's getting more and more accurate. And while that's loading, that would be a good time to talk about my experience helping other people with Python. When I was a instructional assistant at Edison State College, they had a Python introductory to Python class that was taught there. Sometimes the students were confused, so I was one of the few people there that would help them out. They absolutely loved me, and I loved it when they could understand the concepts I taught them. In fact, my most famous student I taught, his name is Drillin Marku. He eventually ended up programming robot arms to build cars, and the few students I've helped with Python absolutely love me. And we're at 85 nodes. It's just getting more and more accurate. At this point, you can basically stop because it's just going to look the same. It's going to get a little more round, but nothing really changes. So that's showing off my Hi, this is Michael Rizzo. This is the final version of my Google Map clone. Let's just go over some of the following features that it has. First off, we clearly see it has store locator, so you know what you're looking for. You have a search box where you can search for your zip code with a working search button, which I can show you right here. I'm going to type in 90048. We get our icons showing up with a list of all our search results. And we can go click in here, and we get our title, when it's open till, its address, phone number, and if you move it over, you also have all the hours it's available in the week. And as an added bonus, I linked it to the real Google Maps, and it'll show you it there too. That's one of the features. I'm showing all the markers here. I have a list. I have the scroll. I have the store list of stores that's scrollable. I just did a pretty basic one. I gotta admit, the hardest part of this project was getting the Google Maps link to work, but now that it works, I feel much better. And getting the hours to show up is really nice. and everything's looked good. It works. This project was hosted on github.io. I tried fast.io, but the code never was fully synced, so I'd rather just stick with what I know and go from there. My portfolio, though, is hosted on fast.io, so that's good. That works well for that. And this is the end of this video. If you have any questions, leave a comment, and have a great day. Hi, this is Michael Rizzo. Today I'm going to be showing off the COVID-19 tracker I built in JavaScript. The front end is chart.js to show the chart, and it shows the little index cards with the infected, recovered, the deaths, and the active cases. And I also made it so you could scroll by country. So if you want to look up United States, for example, you can, and the chart will adjust automatically for that. And then the index cards will also change too. It also works for countries, or if you just want the whole globe, you can do that too. It's a pretty simple project I built. I had a lot of fun with it. Very useful in today's world, and that's this video. Come back for more fun, and that's it.